On April 1st, 2026 at 6:35 in the evening, a rocket lifted off from the Florida coast and aimed itself at the moon. It was the first time in 53 years that a crew of human beings had done that. An entire generation had been born, grown up, had children of their own, and grown old in the gap between that last mission and this one. There were technical problems in the days before launch. A hydrogen leak in February, then a helium leak, a rollback to the assembly building, weeks of delays, and on launch day itself, a sensor anomaly in the flight termination system. The string of charged wires to the fuel tank that would blow up the rocket if it ever lost control delayed the opening of the flight window by just a few minutes. Ground crews checked it, confirmed it was a faulty reading, and cleared the pad. The rocket worked. The crew was ready. What followed over the next 10 days was the most significant human spaceflight mission since the Apollo program ended. There was no landing, no moonwalk, no flag in the ground. What there was a spacecraft that went farther from Earth than any human crew in half a century, and 4 people who came back with something more valuable than rocks. Reed Wiseman, mission commander; Victor Glover, pilot, a Navy captain who had already spent 168 days aboard the International Space Station; Christina Koch, mission specialist; Jeremy Hansen, mission specialist and the first Canadian to take part in a crewed moon mission. Victor Glover became the first person of color to travel beyond low Earth orbit; Christina Koch, the first woman; Jeremy Hansen, the first non-American; Reed Wiseman, the oldest person to do it. All 4 records, 1 mission. The spacecraft they named Integrity, a nod to the teams from across the United States and around the world who built it, including the service module, which was manufactured in Germany under contract from the European Space Agency. Apollo was American from the rivets up. Artemis is international by design. They rode to orbit atop the Space Launch System. At 322 feet tall, it is the most powerful rocket NASA has ever launched. At liftoff, it produced 8.8 million pounds of thrust, 17% more than the Saturn V. 8.5 minutes after ignition, the booster engines shut down. The spacecraft was in orbit, 100 miles above the surface. The crew was alive, and they hadn't even left yet. Before we go any further, there was a problem with this mission, a serious one, and the crew knew about it before they ever climbed into the capsule. When Artemis I returned from its uncrewed test flight in 2022, the spacecraft looked clean from the outside. Splashdown on target, all systems nominal. Engineers called it a success. Then they removed the heat shield panels. The ablative material, Avcoat, a resin compound specifically engineered to char and burn away in a controlled fashion during re-entry, carrying heat away from the capsule, had fractured. Pieces had broken off at over 100 locations. 4 separation bolts had partially burned through their thermal barriers, leaving deep erosion channels instead of clean char lines. The investigation took nearly 2 years. What they found was this: Artemis I had used a skip re-entry technique. The capsule dips into the atmosphere, slows down, briefly bounces back into space, then re-enters a second time. During that pause between contacts, heat accumulated inside the Avcoat. The material generates gases as it processes thermal energy. Under normal, continuous re-entry, those gases vent outward. During the pause, ablation stalled and the gases had nowhere to go. Pressure built, the material fractured. Ground testing had never caught this, because test facilities were running the material at higher heating rates than the spacecraft actually encountered. At those rates, it performed as designed. The moderate sustained heat of the skip pause, lower temperature, longer duration, was the failure mode no test had replicated. NASA's decision, keep the Avcoat, changed the trajectory. For Artemis II, Orion would enter on a direct, steeper path. One continuous descent, no pause, no pressure buildup. The trade-off was higher G-forces on the crew during re-entry. They were told this. They reviewed the investigation reports. They saw the photographs of the fractured material. They launched anyway. In orbit, the crew did what crews always do after reaching space for the first time. They checked everything: life support, propulsion, navigation, communications, thermal control. One by one, system by system, because this was only the second time an Orion capsule had ever flown, and the first time it had ever carried people. Some things didn't work. The first and probably most uncomfortable issue was the universal waste management system, the toilet. The suction fan that drives the liquid waste collection hose had stopped working. For number one, the astronauts had to resort to what NASA calls the contingency urinal, a bag. The Apollo crews did their business in adhesive bags they taped to themselves, in front of each other, and stored in the cabin for the rest of the mission. The Artemis II crew got one step better than that for solid waste, and not much better for liquid. The gap between 1972 and 2026 for sanitation purposes was narrower than most people would like. There was also an IT problem. The crew couldn't log into their official NASA email accounts. Microsoft Outlook and Deep Space failed to authenticate. This will surprise no one who has ever worked in a corporate office. But with every system verified, on the evening of April 2nd, Mission Control voted unanimously to clear integrity for the translunar injection burn. The European Service Module's main engine fired. The burn lasted just under 6 minutes. For the first time since Apollo 17 in 1972, human beings left Earth orbit. From that point, the free return trajectory took over. Gravity did most of the steering. The moon's pull would bring them around the far side and throw them back the way they came. Even if the engine had failed completely after that burn, the physics of the trajectory would have brought the crew home. Apollo 13 used the same path in 1970 when an oxygen tank explosion crippled the spacecraft. It saved 3 lives. It's the safest route to the moon. That also tells you something about the nature of this trip. Over the next 4 days, the crew ran experiments, tested systems, and turned their cameras back toward home. On April 3rd, at a distance of about 100,000 miles from Earth, Wiseman took a photograph with a wide-angle lens on a Nikon D5 camera. The image was later titled Hello World. It shows the entire planet in a single frame, something almost impossible from low Earth orbit, where most spacecraft are simply too close to fit the whole globe into the shot. Most photographs you've seen of Earth are composites, stitched together from multiple images. This one wasn't. The sun was just peeking over the horizon. The light illuminating the night side of the planet was actually moonlight reflecting back. The scene would have looked much darker to the naked eye, but the Nikon's ability to capture detail in extreme low light brought it forward. The communication delay at lunar distance is about 1.3 seconds each way, enough to make every exchange with Houston feel slightly off. You can say something, you wait, the reply comes back a beat late. A small thing, but a constant quiet reminder of how far they had actually gone. Inside the capsule, no shower. Hygiene was wet wipes, dry shampoo, liquid soap. Food came from pouches. A briefcase-sized warmer heated some items. Most meals were eaten floating at whatever temperature the pouch happened to be, while chasing crumbs before they drifted into an air filter. Sleep was in tethered bags on the walls of the cabin, all 4 at once. The life support system never stopped. It circulated oxygen, scrubbed carbon dioxide, managed temperature. It sounded like the machine keeping them alive, because that was exactly what it was. After 4 days, the moon stopped being a light in the sky and started being a place. At their closest approach during the flyby, integrity passed approximately 4,000 miles above the lunar surface. The Apollo missions orbited at a few hundred miles. The difference in perspective is enormous. At that distance, the moon doesn't fill a fraction of the window, it fills the whole thing. Pole to pole, edge to edge. Wiseman described it as unlike anything training had prepared him for. From partway through the transit, he could already see the entire globe, Africa, Europe, and when he looked closely, the northern lights tracing a faint arc across the top of the planet. And the moon was not what anyone expected. From Earth, it looks gray, uniformly gray, like concrete. Up close, the crew saw something different. Distinct hues of brown across the ancient highlands, a faint green in certain impact crater regions, subtle blue tints in areas where the mineral composition shifts. These color variations matter scientifically. They reveal the relative age of surface features and their mineral content, information that orbital cameras tend to flatten into uniform gray. Human eyes can see a far wider dynamic range between light and dark, and a far broader spectrum of color than any camera sensor currently flying. Koch noted that the freshest impact craters, The ones with the lightest color surfaces stood out so sharply against the ancient terrain that they looked like tiny pinholes in a lampshade, glowing white against everything around them. This kind of nuance, the kind you only get with a trained human eye and direct observation, is precisely what this mission was designed to capture. The crew also identified two previously unnamed craters. One they proposed calling Integrity after their spacecraft, the other, Carol, after Reed Wiseman's late wife, Carol Taylor Wiseman, who passed away in 2020. Carol crater sits right on the boundary between the near and far sides, a bright spot that is visible from Earth if you know where to look. Hansen described it simply as a bright spot on the moon. It will be there long after every person alive today is gone. Then Integrity crossed the Orientale Basin, a nearly 600-mile wide impact scar, 3.8 billion years old, straddling the boundary between the side of the moon we see every night and the side we have never seen with human eyes. And the far side of the moon began to reveal itself. Most people have heard it called the dark side. That name is wrong. It receives exactly as much sunlight as anywhere else on the moon. What makes it different is this: it always faces away from Earth. In all of human history, no person has ever seen it directly, only through satellite images, orbital cameras, and processed data sheets. The Artemis II crew saw it through the windows of their spacecraft. The first thing that strikes you in the images is the absence of the dark plains. The near side of the moon, the one we've drawn and painted and used as a clock for 10,000 years, is covered in vast, flat maria, ancient lava flows that filled enormous craters and cooled into dark basalt seas billions of years ago. About 31% of the near side is covered in this volcanic rock. It gives the moon its face. The far side has almost none of it, less than 1%. Instead of smooth plains, the far side is a landscape of craters stacked on top of craters stacked on top of older craters. The crust is roughly 50 kilometers thicker on the far side than the near side. No one fully agrees on why. The leading theory involves a cataclysmic impact near the moon's south pole, so violent that it sent a wave of heat through the entire interior, shoving rare Earth elements toward the near side. That impact left behind the largest preserved crater in the entire solar system. The South Pole Aitken Basin. It stretches roughly 2,500 kilometers across and plunges up to 13 kilometers deep. If you placed it on a map of the United States, it would swallow everything from Texas to Virginia. The mountains along its rim reach elevations of 8,500 meters. And buried beneath its floor, something is hiding. A mass anomaly, a blob of dense material sitting at least 300 kilometers below the surface, weighing at minimum 2.18 quintillion kilograms. The most likely explanation is that it's the metallic core of the asteroid that punched the hole, still lodged in the moon's mantle after 4 billion years. Like a bullet fragment, the body never managed to push out. The Artemis II crew became the first humans to see the eastern edge of this basin with their own eyes. Not through a robotic camera, not in processed data, through the windows of their spacecraft. Before the communications blackout hit, the crew reported observations in real time to a science evaluation room in Houston that was updating the flyby plan on the fly, sending new guidance based on what the crew was actually seeing. Glover became fixated on the terminator, the shifting line between sunlit and shadowed terrain. Along that boundary, the low angle of the sunlight creates extreme contrast. Crater rims lit from below, shadows so deep they look like holes punched through to the moon's core. He radioed that the terminator was full of magic, that the islands of light and the valleys of dark looked like black holes you could fall straight through to the center of the moon. He was trying to describe something that the camera images simply hadn't prepared the science team to see. Koch and Hansen were simultaneously photographing the Vavilov crater, perched on the rim of the older and larger Hertzsprung basin, deep on the far side. The science team had flagged Rena Gamma as a priority observation target, a bright, swirling pattern across the near side surface, sprawled like someone dragged a white paintbrush across dark rock. It has no elevation. It's not a crater or a volcanic deposit. It's a flat optical marking that aligns precisely with a localized magnetic anomaly in the crust beneath it. The moon has had no global magnetic field for billions of years, yet patches of magnetized rock persist, scattered through its crust like ghosts of something that used to protect it. No one fully understands what is keeping Rena Gamma bright. In 2023, researchers detected a thermal anomaly buried beneath the far side surface, a region about 50 kilometers wide that registers roughly 10 degrees Celsius warmer than everything around it. The likely source is a massive buried block of granite, a rock type common on Earth, almost unheard of on the Moon, because granite requires water and plate tectonics to form, neither of which the Moon possesses. The researchers believe it may be the remnant of a volcano that went dormant 3.5 billion years ago, its residual magma still radiating faint heat. Lead scientist Matt Siegler noted that the finding looks far more like something on Earth than anyone had thought possible. It raised a question nobody expected to be asking. What else is still warm under there? As Integrity rounded the far side, something was happening that no human being had ever seen before from this angle. A total solar eclipse. Not the kind visible from Earth where the Moon blocks the Sun. This one happened the other way. From the crew's position behind the Moon, the Earth slid in front of the Sun and blocked it. From Earth, total eclipses last 8 minutes. From here, totality lasted nearly 54 minutes. The Sun's corona, its outer atmosphere, flared outward in a complete halo, bright enough, Glover reported, to ring the entire Moon. Hansen described sunlight illuminating the full perimeter of the lunar disk, ridges and peaks silhouetted against the burning white edge of the Sun's atmosphere. The crew photographed the Moon with the stars and planets visible in the background, something never possible from Earth, because the Sun is always present during the Moon's daytime. During the eclipse, both Hansen and Wiseman reported seeing what appeared to be impact flashes on the lunar surface. Momentary bursts of light that could have been small meteorites striking the unprotected far side. The Moon has no atmosphere, no magnetic field, nothing between its surface and the full force of space. Every particle hits the far side with nothing to slow it down. Scientists in the evaluation room asked for more details. Both confirmed at least one brief flash, though they couldn't say how long it lasted. Whether they witnessed a meteorite impact, an electrostatic dust plume, or something else entirely, no one can say for certain. Before the blackout hit, the crew watched something else, an Earthsat. Earth, blue and small and faint, slowly sinking below the horizon of the Moon, disappearing behind gray cratered rock. Koch described the moment simply. He said that having this perspective and comparing it to home reminds you how much we all have in common. That everything we need, Earth provides, and that you can't fully understand that until you've seen it from the outside. At 6:44 in the evening Eastern Time, the Moon passed between Integrity and Earth and the signal cut off. For 40 minutes, no voice reached them. No telemetry left. No abort command could have arrived. 4 people in a capsule roughly the size of a large van, separated from the entire human world by 2,160 miles of solid lunar rock. The science protocols continued. The cameras kept running. The crew had trained for this. None of that changes what those 40 minutes actually were. When the signal came back, Houston erupted, and when Integrity cleared the far side, the crew saw Earth reappear over the lunar horizon. An Earthrise, echoing the photograph Bill Anders took from Apollo 8 on Christmas Eve in 1968. Except this time, Earth was rising back into view for the first time after an absence. The crew was flying through solar maximum, the peak of the Sun's 11-year activity cycle, when the risk of solar particle events is at its highest. A severe storm can push radiation to nearly lethal doses within hours. Apollo astronauts reported seeing flashes of light with their eyes closed during their missions, cosmic rays punching through their retinas. Some later developed cataracts at unusually high rates. 24 people have ever left Earth's magnetic protection. The sample size is too small to draw statistical conclusions and too small to dismiss the risk. Orion provides more shielding than Apollo ever did, but galactic cosmic rays originating from supernovae and other cataclysmic events move at nearly the speed of light and penetrate almost any material we've built. Alexandra Stankovich, founding director of the Center for Space Medicine Research at Massachusetts General Hospital, has called deep space radiation the #1 limitation to how far humans can explore. Aboard Integrity, the Avatar payload carried bone marrow cells derived from the crew's own blood. to study how those cells respond to the deep space radiation environment after the mission. That data will inform crew protection protocols for every future mission that goes farther and stays longer. It will matter for the path to Mars more than any photograph taken during the flyby. After the flyby, the moon's gravity redirected Integrity back toward Earth. The crew spent 4 more days crossing the distance home, monitoring systems, running medical checks, photographing everything they'd seen on their way out while processing the memory of having seen it. Glover, when Orion cleared the far side and Earth reappeared in the windows, said something that cut through the technical language of everything else he transmitted during the mission. He said the moon is not just a poster in the sky that goes by, it's a real place. He's right, and the more the crew described what they saw, the more clearly that registered. The craters that were taller than they looked in orbital images, the surface nowhere near as flat as it appears from a distance, with steep cliffs and rugged peaks around impact sites. The Terminator's magic, the color of the rocks, the Earth set, the things that no orbiter image has captured because no orbiter has human eyes. The crew took thousands of photographs during the flyby. Most hadn't been downlinked before splashdown due to bandwidth limitations. The full image set only became available after recovery. NASA has said those photographs of craters, ridges, ancient lava flows, the eastern edge of the South Pole Aitken Basin could reshape maps of the moon's geological history and directly inform where future Artemis missions land. A site that looks flat and safe in an orbiter image might look entirely different when a trained human eye sees how shadows pool along the Terminator in ways that cameras flatten. The re-entry on the way home is the moment the entire 2-year heat shield investigation either proved itself or didn't. About 20 minutes before reaching the atmosphere, pyrotechnic charges fired and separated the Integrity capsule from the service module. The crew no longer needed it. The service module burned up on its own re-entry. The capsule fired its maneuvering thrusters, flipped, and put the heat shield pointing down into the direction of travel. Integrity accelerated to a top speed of about 32 times the speed of sound as it fell through the upper atmosphere. The capsule began slamming into air molecules, still thin at this altitude, but dense enough to start the heating process. Temperatures at the shield face climbed toward 4,000 to 5,000 degrees Fahrenheit. At that temperature, the air molecules in front of the capsule don't compress. They explode into plasma. Not only superheated, but electrically charged. The plasma conducted electricity and disrupted every radio signal between the crew and the ground team. The windows glowed orange, then white. Communications went dead. From the outside, the Integrity was invisible behind a sheath of ionized fire. Inside, the crew felt the deceleration building, a force of about 4 Gs, 4 times the pull of Earth's gravity, pressing them into their seats. Breathing required deliberate effort. Moving required effort. For 6 minutes, the crew was completely unreachable. No voice from Houston, no telemetry, nothing except the sound of a spacecraft absorbing more heat than any surface the crew would ever stand on, and a heat shield that had cracked under less severe conditions the last time it was used. The avcoat was supposed to ablate smoothly on the direct trajectory. No skip, no pause, no pressure buildup. The gas is venting continuously as the material charred in one uninterrupted descent. When the plasma faded and communications returned, Houston heard the crew, all 4 in good health. At an altitude of around 5,000 feet, the main parachutes deployed. Integrity slowed to a final descent speed of 19 miles per hour. And at 5:07 in the afternoon local time, the capsule hit the Pacific Ocean off the coast of San Diego, completing a journey that covered a total of 695,081 miles, from Earth to the Moon and back. Conditions in the Pacific were relatively calm. Waves peaked at about 4 feet high. The capsule deployed 5 red helium balloons from the nose to keep it stable and upright in the water. Recovery ships had been waiting. There was one minor issue. Wiseman reported he could hear the recovery crew, but they couldn't hear him. The communications between the capsule and the rescue boats had a one-way fault. Recovery boats circled the capsule for a few minutes, waiting for instructions that weren't coming through. Eventually, the first boat moved in and opened the hatch from the outside. 4 people took their first breath of unrecycled air since the previous Wednesday. 4 Navy officers from the recovery boat entered the capsule and began checking each astronaut, helping them out of their harnesses and helmets, preparing them for what comes next. They attached a large inflatable raft to the outside of the capsule beneath the open hatch. One by one, the crew dropped from the capsule onto the porch and waited for a line down from a recovery helicopter. 2 helicopters ran the operation, lifting 1 astronaut at a time from the porch and transferring them to the deck of a Navy ship waiting nearby. From there, straight to the medical bay. All signs throughout landing and recovery pointed to all 4 astronauts in good health. They would be monitored for weeks because 10 days in deep space during solar maximum leaves biological traces that take time to fully measure. But they were home. They were standing or trying to stand, their inner ears recalibrating to a world where down means something again. Apollo proved we could leave. Artemis is figuring out how to stay gone. Every system the Artemis crew tested, the heat shield, the life support, the navigation, the communications, the laser data link, the exercise equipment, the sleep restraints, the radiation monitoring, was being validated not just for the next lunar mission, but for the missions after that. Orion has already been evaluated for a 1,000-day mission profile when paired with additional habitation modules. The data the crew collected about their own biology in deep space will directly shape the spacecraft and mission plans that eventually send the first humans to Mars. The Apollo astronauts came home as conquerors. They had a target and they hit it. When the Artemis II crew came home, they came home as something different. The first generation of deep space humans in half a century, carrying data that no robotic mission could have produced, observations that no camera could have captured, and the testimony of 4 people who went farther from Earth than any living person had ever been, and came back to describe what they found. The moon is not what we thought it was. Its far side is not gray and uniform and quiet. It is a wall of ancient violence, a crust thicker than anything on the near side, a buried mass that warps local gravity, heat sources that shouldn't exist, magnetic ghosts in rock that lost its field billions of years ago, and a solar silence so complete that radio telescopes built there could hear the universe more clearly than anywhere else on Earth. Victor Glover, after integrity cleared the far side and Earth reappeared, said the moon is not just a poster in the sky that goes by. It's a real place. And we've barely begun to understand it. The far side of the moon still holds more questions than answers. Every answer it gives opens 3 more. The granite that shouldn't be there, the mass that doesn't match, the asymmetry between hemispheres that no single theory explains, the heat that's still rising from something buried 3.5 billion years deep. Artemis II was not the end of anything. It was the first step of something that will take decades. The heat shield passed. The crew came home. The door that closed in 1972 has been reopened. Not the door to the moon. We opened that a long time ago. The door to going back. Artemis II made it home, but this mission didn't happen by accident, and it didn't happen for free. Watch the 31 heroes that were sacrificed to make Artemis II possible, because the real cost of getting to the moon isn't measured in dollars.